Hi, you are welcome to GMats class. Today we want to look at the question under variation. Let's look at the question. The electric conductivity in a wire of a circular cross section varies directly as the square of the radius and inversely as the length. One wire is twice as long as the other, but the radius of the cross section of the shorter is 3/2 times that of the longer. Find the ratio of their conductivity. Now the first thing you need to know here is to get the parameters that are being varied. So where are the parameters? So the first one we have here is conductivity. As you can see, the electric conductivity in a wire of a circular cross section varies directly as the square of the what? The radius. This is the second parameter. And inversely as the what? The length. So we have three parameters here. Okay, so now we start by saying let's see the equals to conductivity of the wire, and also we have the radius R to be the radius of the wire, and L to be the length of the wire. So from here we can now turn this to a mathematical statement. So let's read through the question again. Now, the electric conductivity in a wire of circular cross section varies. Conductivity in a wire, C, varies, this is the symbol of vary, varies directly as the square of the radius, and our radius is R. That's going to be R squared, and inversely as the length. So this is the variation. Now from here, this variation will give us this. So C equals to KR squared over L, where K is what? A constant. So now let's move on. Now, one wire is twice as long as the other. Now that gives me an idea that we have two wires. So we have a longer wire and a shorter wire. And each of the wire will have their conductivity and they will have their radius. So in that case, so I need a symbol to represent the parameters of the shorter wire and the longer wire. So I will start by saying let's C1 L1 and the what? R1 to represent the what? The conductivity. Comma, second one, the length, and the radius of the wire. So of the wire. Now, not just ordinary wire, the shorter wire. Okay, so now let's write shorter wire instead of wire. So shorter wire. So C1 is the conductivity, L1 is the length, and R1 is the radius of the shorter wire. So now let us use an alphabet for the longer wire as well. So we say C1, C2 now, C2, R2, and L2 represents the conductivity, radius, and what? And the length of the longer wire now. Longer wire. Okay? So, now let's move to the question now. One wire is twice as long as the other wire. So that means the longer wire is twice the shorter wire. So the longer wire, that means L2 will be equal to 2L1. Okay? So one wire is twice as long as the other. Now, we are also given that, but the radius of the cross section of the shorter wire is 3/2 times that of the longer. You get that now? The radius of the shorter, that is R1, which is the radius of the shorter, now is equals to what? 3/2 times the radius of the longer. The radius of the longer. Alright? So, now when you look at this, I can make R2 to be the solid of the formula. So I will divide both sides by 3/2. So when you do that, so we have what? We have R2 to be equals to 2/3R1. So when you divide this by 3/2, so if you turn upside down and multiply itself with R1, okay, so like this, R1 divided by 3/2, that gives you R1 times 2/3. Okay, so, and it gives back to that. Okay, so that's R2. Okay, so the next thing now is to substitute inside this equation. So for the shorter wire, we have C1, because the conductivity of the shorter one is C1. C1 equals to, I'm using this formula now, K times R1 square all over L1, the length of the shorter wire. Okay, so now let's look at that of the longer wire. So C2, I'm substituting inside this equation. C2 equals to K times R2 now. R2. So now look at R2. R2 is 2/3R1. So I'll write 2/3R1. So this is my R2 now. Everything all over L2. What is L2? 2L1. Hope you get that now. Okay, so from here, let's try and tidy up this. So we have C2 will be equals to, so when you square this one, when you square 2, you have 4. When you square 3, you have 9. When you square R1, you have R1 squared. So this will now give you, the numerator will give you 4/9 times K times R1 squared all over 2L1. I hope you get that. Now this K is this. So you are squaring this. So you square 2, you have 4. You square 3, you have 9. You square R1, you have R1 squared. So all over 2L1. Okay. So now to get the ratio now, R1 ratio R2. That gives you have this divided by this. Okay, so we have K R1 squared over L1 divided by 4 KR1 squared over 9 divided by 2L1. Hope you get that now. This one is this. Okay? Alright, so now when you tidy up this one, you'll be having, you know, what I have here is this. The numerator is this. This is the denominator now. So I will turn this to multiplication. So once I turn this to multiplication, this one change. So let's do it step by step now. So we now have KR1 squared over L1 divided by 4K R1 squared over 9, okay, times 1 over 2L1. So when you do that, you know this one will multiply this. So that is going to give us KR1 squared over L1 times everything in the denominator moves up. This one comes down. So we have 9 times 2 times L1 over 4KR1 squared times 1. You get that now? So once you turn this division to multiplication, so the denominator comes up, the numerator comes down. So we can now cancel. This cancel this. K will cancel K. This will cancel this. Okay, so 2 goes here is 2. And 2 goes here is 1. So what we are left with now is C1 ratio C2 gives you 9 over 2. Okay, so, and that's the same thing as C1 ratio C2 equals to 9 ratio 2. So, and this is the answer. That is, the ratio of the conductivity of the smaller wire to that of the longer wire is what? 9 to 2. 9 to 2. So that's the result.